Imagine you need to know the exact height of this slide, but you can't reach the top with a tape measure. Measuring the steepness or the length of that metal drop from the ground seems like a guessing game. But every slide is built using two main paths. You have the upright ladder the kids climb, and the diagonal surface to get back down. If you draw a straight line along the ground to connect the ladder to the end of the slide, you can see the structure for what it really is, a three-sided shape called a right triangle. Trigonometry is the study of how the sides and angles of this specific shape relate to one another. By understanding these relationships, we can calculate distances that are physically impossible to measure by hand. To start, we need a consistent perspective. We'll pick the corner where the slide meets the grass and mark it with this symbol, called theta. This is our anchor point for every measurement we take. From our spot at theta, the longest side of the triangle, the part you actually slide down, is called the hypotenuse. No matter how you turn the triangle, the longest side always keeps this name. If you look across the triangle at the ladder, you're looking at the side farthest away from your position. Because it sits across from theta, we call this the opposite side. Finally, the flat ground connecting your seat to the ladder is called the adjacent side. In geometry, adjacent simply means the side that is right next to our starting angle. Naming these sides is the first step in the process. Because the math depends entirely on your perspective, you have to identify which side is which before you can use any formulas. Suppose the ladder is 3 units high, and the ground is 4 units long. The square of these shorter sides equals the square of the longest side. Since 3 squared plus 4 squared equals 5 squared, the slide itself is exactly 5 units long. This works perfectly for finding lengths when we have whole numbers, but it doesn't tell us the angle of the slide. It also gets complicated when the measurements are fractions or decimals. To solve for missing angles, we use the fact that the ratio between two sides is always constant for a specific angle. We just need a way to remember which sides to compare. To keep these ratios straight, we use the word SOHCAHTOA. This memory tool tells us exactly which triangle sides to divide to find our answers. SOH stands for sine, the opposite side divided by the hypotenuse, or 3/5. CAH is cosine, the adjacent side divided by the hypotenuse, 4/5. Lastly, TOA is tangent, the opposite side over the adjacent, giving us 3/4. This word removes the confusion of which side goes where. The middle letter of each chunk tells you which side is the top of the fraction, and the last letter tells you the bottom. Because these proportions are constant for every angle, SOHCAHTOA gives you a reliable formula. If you know the angle and just one side, you can calculate the rest of the triangle without ever leaving the ground. These relationships appear in almost every construction project. If you were building a skateboard ramp, you would use these ratios to ensure the incline is safe and that you have enough wood for the surface. The height of the frame is your opposite side. The driveway is the adjacent, and the surface you ride on is the hypotenuse. The math for the ramp is identical to the math for the slide. You can even use this to calculate the height of a kite. Even though you can't walk a ladder up into the clouds, the triangle is still there. The string serves as your hypotenuse. If you know the angle of the string and how much line you've let out, you can calculate the length of the imaginary vertical line dropping to the grass, the opposite side. This is how engineers design roof pitches and how surveyors map out land. It turns the physical world into a series of predictable, manageable measurements. Once you can identify the 3 sides and remember the word SOHCAHTOA, you can analyze the geometry of your surroundings just by looking at them. You can find these right angles in everyday objects, like a ladder leaning against a house or the corner of a park bench. With one memory tool, you have the foundation to understand how these shapes work. Next, we'll look at how to use these same triangles to solve even more complex problems using cosecant and secant. See you in the next lesson.